Hours before this rig exploded, the system that was supposed to catch the failure worked. A safety test ran and the warning was right there on a pressure gauge, 1,400 pounds per square inch where the procedure expected 0. The crew saw it, they discussed it, and then the well was declared sealed. Why would experienced people read a failed test as a passing one? This is the story of the negative pressure test on the Deepwater Horizon, the last clear chance to stop the Macondo blowout before it happened. Not the fire, not the spill. The 40 minutes of gauge readings and the 2 different stories people told themselves about what those readings meant. Everything in this episode comes from the official record. The Federal Joint Investigation Team report by the Coast Guard and the offshore regulator, the Chemical Safety Board's engineering investigation, and the National Commission's report to the President. First, the setup. April 2010. The Deepwater Horizon is a mobile offshore drilling unit finishing an exploration well called Macondo in about 5,000 feet of water in the Gulf of Mexico. 126 people are on board. The drilling is done. The well has found oil and gas. The job now is to seal it temporarily so the rig can move off and a production platform can come later. The seal has layers. At the bottom of the well, a cement job plugs the space between the steel casing and the rock. Cement is the physical barrier holding the reservoir back. Above it, the well is full of heavy drilling mud, whose weight also pushes down against the reservoir. The plan for temporary abandonment was to replace much of that heavy mud with lighter seawater. But you only dare do that if the cement barrier at the bottom actually holds. Because you cannot see the cement 3 miles down, you test it with pressure. Keep that detail in mind. The whole anomaly lives inside this test. The negative pressure test works like this. The crew deliberately reduces the pressure inside the well below the pressure of the reservoir outside it. If the cement is sealing, nothing happens. Pressure inside stays low and nothing flows. If the cement is not sealing, the reservoir pushes in and you see it, as pressure building back up. Or as fluid flowing where it should be still. There is one more piece of context the record makes clear. This crew was doing all of this on a well that had already been difficult. The operator's own engineers had called it a well that fought them. The cement job at the bottom was a technically delicate one. A light nitrogen-foamed cement, placed in a narrow margin between fracturing the rock and failing to seal it. The lab data supporting that slurry design was thin. None of that was visible from the rig floor. What was visible was a gauge. On the evening of April 20, the crew ran that test. The record shows the pressure on the drill pipe did not stay low. It built back to about 1,400 psi. They bled it down. It built back again. A sealed well reads 0. This well kept saying 1,400. Then came the explanation. A crew member proposed that the reading was a quirk called a bladder effect, the idea that mud weight above a closed valve could transmit pressure to the drill pipe gauge and produce a false reading. The investigations later searched for an engineering basis for that explanation. The Chemical Safety Board reported it could not find one, so the crew moved the test to a different line, the kill line, and watched there instead. No sustained flow. That line reads 0, and on that basis the test was declared a success. But the drill pipe gauge still read 1,400 psi at that moment, 2 gauges on the same well telling 2 different stories. One of them had to be wrong, and the well only gets a vote if somebody asks it again. What the record shows next is the anomaly finishing its argument. With the test accepted, the crew went back to displacing heavy mud with seawater. The reservoir, which had been pushing through the failed cement the whole time, now had less and less weight holding it down. Around 9:40 that night, drilling mud began flowing up onto the rig floor. The flow was routed to a mud-gas separator that was never designed for that volume. Gas spread across the deck and found an ignition source. The first explosion came at about 9:49. 11 workers died that night. 115 others got off the rig. 36 hours later, the Deepwater Horizon sank. The blowout preventer, the BOP, the last mechanical defense on the seafloor, was commanded to shear the pipe and seal the well. The forensic examination found it could not. The drill pipe had buckled off-center inside the stack. outside the blade's effective reach, and the investigation also found maintenance faults in the control pods, including a miswired solenoid valve and a low battery. The well flowed for 87 days. The Federal Flow Rate Technical Group estimated roughly 4.9 million barrels of oil released before the well was capped in July and finally killed from below in September. The investigation's finding on the test was direct. The negative pressure test was the point where the failure was visible and recoverable. The cement barrier had already failed. That was the first failure hours earlier and out of sight. But the test surfaced it. 1400 psi was the reservoir itself, communicating up the drill pipe. The anomaly was not ambiguous because the data was bad. It was ambiguous because two readings disagreed. And the explanation that resolved the disagreement was never tested. And here is the system's finding, the one this channel exists for. At the time, the record shows there was no standard procedure and no written acceptance criteria for a negative pressure test, not in the operator's program for that well and not in the federal regulations. Each crew interpreted results as they came. A test with no pass-fail line printed in advance is not a test. It is a conversation with the well, and the well was outvoted. The investigations also traced why the conversation went the way it did. The people reading the gauges that evening were in the middle of a shift handover, working from a temporary abandonment plan that had changed several times in the final days, on a job that was weeks behind schedule. Nobody in that chain woke up careless. The finding is harder than carelessness. Normal people under normal production pressure will reliably choose the comfortable reading of an ambiguous instrument, unless the procedure forces the uncomfortable one to be ruled out first. That is what an acceptance criterion is for. It is a decision made in daylight in advance, so it does not have to be made at night under pressure by whoever happens to be standing at the panel. So the fix was not one heroic trick, and it was not blaming one crew. The finding drove structural change. The offshore regulator was broken up and rebuilt. The agency that both sold drilling leases and policed them was split, creating a dedicated safety regulator, the Bureau of Safety and Environmental Enforcement. New drilling safety rules made negative pressure testing an explicit regulatory requirement with documented procedures. The industry rewrote its blowout preventer standard, and the 2016 well control rule added equipment, testing, and real-time monitoring requirements on top. The deeper recommendation from the record is about anomalies themselves. When two instruments disagree, the disagreement is the data. An explanation that makes an alarming reading comfortable without a test that could prove it wrong is not analysis. The Chemical Safety Board's report treats the bladder effect as exactly that, a plausible story that dissolved a warning. The gauge said 1400. The well meant it. Everything after was the cost of explaining it away. The record is public. The Joint Investigation Team report, the Chemical Safety Board's Macondo volumes, and the National Commission's report to the President. The full citations are in the description.